Okay, so last time we just got the basic kind of functionality working with this field's name Jack, and now I think we want to go and actually start building an actual generator. So the first generator that is used in the docs is the fake one, which will use the faker.js library. We can probably leave that one for now, so that's going to be a bit more complicated. So I want to try sequence, because all that happens here is every time you create a new factory, it gets a sequence count, and then every time sequence is called, it increments it by 1. So in theory, that should be fairly straightforward for us to do. So we'll see. So build needs to return, it returns this function down here. So if we want a per factory counter, we can define it in the scope here. What I'm also going to do is let this build function grow big and then refactor it later on. I expect we'll end up with a class of some stuff in, but for now we're going to say let sequence counter equals 0, like so. And what I'm actually going to do first is let's write a test for it. So let's just make this window over here a little bigger. In fact, what I'm going to do is just kind of make, there we go. Just make the code. We don't really need the browser at the moment, so I'll just leave it there. So let's rename this first. It can build an object with primitive values only. And let's describe sequence test. It increments the sequence value per build. Okay, so I'm going to go up here. I'm going to copy all that. So user build user, and we'll say fields, and we're just going to say ID sequence. I'm going to say user. In fact, let's do const users equals user builder. So we'll call it twice. And what we can do is we'll expect users to equal ID1, and then we'll have another user with an ID of 2. Like so. Oh, and this needs to be wrapped in an array. Okay, so it's moaning about not being able to find sequence, which is correct. So what we'll say is we can just import sequence like that. I've always quite liked that everything is just on the top level, so I don't really want to change that. However, this does mean now that we need to define this sequence function somewhere. So I'm also struggling with the vertical room here, so I'm actually going to move the terminal over there for now, and then we get a bit more vertically, which I would prefer. Let's pull that out. Okay, so in fact, what we can do is just close the test for a minute because we don't need it anymore. So we need to export a function called sequence, and let's just define that as an arrow function for now, and it's returning nothing. So I think we're going to get some errors. Let's try and run the test and see what happens. Because I think what it should do is realize that sequence isn't fulfilling the types. There we go. Type void is not assignable to type field. I think to define a return type, you put it here. So this is going to be a field generator, like so. And a field generator currently for us is just a function that returns a string. So obviously that's not what it's going to be long term, but I can just say return foo here. And I think that's going to pass it because foo is a field generator. Type foo is not assignable to type field generator. It's a function that returns a string, of course, so we can just do that. And that should keep the types happy. So now if we run the test again, they're still going to fail, but I don't think they'll fail because of types. I think they'll fail because foo is not an ID. And in fact, it's just returning an anonymous function, which is actually what I expected. So what the sequence generator needs to do is it needs to return a function that returns ++ sequence counter. So it's going to increment it. Sequence counter. I still can't type. And of course, this value isn't in the scope. So actually, what I think sequence counter will have to do is be passed in a value. So here we'll have to take. How are we going to do this? Because different generators are going to need different things passed into them. So I'm just trying to figure out the best way to type those. Maybe we actually define generator types for each of them. So maybe we do that. So maybe let's say sequence will take in a counter and it will increment it and return it. So ++ counter. Okay, great. And counter will be a number. And I think I have to put brackets around that. And I think the error here will be because that's not what field generator does. Yeah, not assignable to type field generator. That's fine. So what I'm actually going to do is say type sequence generator. is going to be a function that takes in a number. I think can I do that? And it's going to return a number. Is that valid, or do I have to say like counter is a number? And then return like that. Great. Okay, so then sequence isn't a field generator anymore, it's a sequence generator. And then a field generator can be, let's say it can be that, or it can be, or a sequence generator. Great, this feels like we're heading in a good direction. So now the fields to return, we need to loop over that. And we actually just want to do this. I'm still not sure about this sequence counter just kind of floating around here, but it will do for now. So what we now need to do is we need to check the type of this current field as we loop over it. If it's a primitive value, we can just return it, and that's great. If it's a generator though, then we should actually call that or kind of do whatever we need to make that generator work. So what I'm thinking is we're going to need to loop over all these fields and call these generators, but we need to know what type of generator each one is. So maybe actually we say that a generator is an interface field generator, and it's going to have a function called __ type, and that will be a string, and then it can have the call maybe as the function, and this will be say a sequence generator or a string generator. And let's get rid of that. So maybe we have that. Or is it not like that? No, I think I do want that there, so why doesn't it like that? Passing error type expected. Do I have to wrap that in brackets? Yes, okay. Great, so now we're saying a field generator has a type field and a call function. So this sequence now does need to become a field generator. So it's going to return a field generator. So rather than return this, what we're going to do is return __ type sequence, and then the call is the function that takes a counter, which is a number, and returns ++ counter. Get rid of that. Okay, I think that's correct. And this type, maybe this needs to be like a kind of TypeScript. Is it an enum we can use? But I think we'll leave that for now. Okay, great. So over here, and we can say const field name field value equals current field. We'll just do some destructuring there. So if field value dot __ type, which it may or may not have, so that's why we're checking. Else, and let's say let calculated value equal. We'll just say that actually. If we have a type, then we need to do something with that. Else, we can say calculated value equals just field value, and we'll return here the field name down here because we now destructured. So let's make that field name, and this will be calculated value. Okay, so if we look at the field value here, it's a field, and a field is a string number or a field generator. So property type does not exist on that type. It does not exist on a string. That is correct. But I kind of know that, and I want to do that check here. So I'm back. I didn't want to do too much coding behind the scenes, but I just spent a bit of time Googling. I think this type guards thing is what we want here. So it's saying that, as we mentioned, you can only access members that are guaranteed to be in all the constituents of a union type. So that's the problem here. Is it's saying, well, I can't access, this was __ type, I've renamed it generator type just to be a bit clearer. It's saying that we can't access that because that's not on string or number, which does make sense. And so to get the same code working, it says we'll need to use a type assertion, which you can do. However, it also says we can define a type guard, so we can define a function that says is fish and do this pet is fish thing. And then that will tell TypeScript that the kind of type has been narrowed. So narrowing a type here means TypeScript thinks field is string, number, or field generator. I want to narrow that so TypeScript realizes it's only a field generator. So I think what I can do is define a function called isGenerator. What it's going to do is take in a field, which is a field type. And if it returns true, then it's going to say, we're going to say field is field generator. Can I do this? Is that valid syntax? Let's just keep going anyway and return, and we need to cast it to the thing we think it might be, so field field generator. Oh, whoa, it's definitely not JSX. Let's not do that. Field generator, and then it says pet, so field dot generator type is not equal to undefined. Okay, I think that's what we want. What's this error here? Prefer as field generator instead of field generator. Okay, don't know why, but don't necessarily know why that's advised. At field as field generator. Okay, and the only warning now I think is just that isGenerator is unused. Yeah, declared, but its value is never read. Excellent. Okay, so rather than saying if field value.generator type, what I think we want to say here is if is generator field value. Great, and now notice that there's no error here because it knows generator type exists because field value is a field generator. So we can call generator type and we can call the call function. Else down here, it knows that field value is now a string or a number because it cannot be a generator. So that's really good. That's excellent. Okay, and I still can't help shake the feeling that we could do something with this switch case to make sure we cover all cases of generator type. I thought that might even work for us. We'll leave that for now. But what I think we can now do, let's make this window a bit bigger and also make the terminal a little bit bigger, is I kind of want to run our tests and see where we're at. Okay, excellent. So increment to sequence value per build, expected and received. Okay, so we're expecting 2 and we got 1 both times. So that's definitely a bug somewhere. But it's also exciting that it is kind of working. And we're starting it at 0. So the first time we call it, we should increment it and get 1, and then we should call it again. Yeah, so I think what's happening here is this. The value isn't being passed through correctly, right? So we need to do, what we'll do is we'll do it here. So we increment it, then we call it with the new value of the sequence counter. So down here, this literally just needs to become a function that returns the counter it's given. Okay, let's try that again. Great. So yeah, the problem there was we're passing in the number, but sequence then just increments it within its own function scope. So actually we'll just have to do the incrementing here and then pass that value in. And then the sequence counter just returns a counter that returns a number. That is all good. Great, and all our tests are passing. So this isn't perfect, there's obviously a lot of work here to go, but I think that's a really nice step in the right direction. Now getting kind of the first generator done, we've done a lot of infrastructure stuff, so I'm excited to see how we do as we keep building this out.